Okie dokes, we're going to be on page 24 and we're going to be doing some histogram analysis. So that means we're going to be taking a look at histograms that have already been made, which is nice. And we're going to be using the information from the histograms to help us answer a variety of different questions. And we're actually going to start out with a histogram that may look somewhat familiar. This is daily visitors to state parks. This is a similar histogram to the one we were looking at yesterday, but you can see they don't have a gap here in this interval. I know we had 0 there yesterday, but they have a data point here, and I think we moved that data point to this interval here because we had 2 here yesterday. So similar data, not the same. So the first thing I'm going to do here before we even answer the questions, I'm going to write the frequency of each histogram bar above the bar. So 100 to 149 is 2, 150 to 199 is 7, 200 to 249 is 8, and then these are all 1. Even though they look like they're like a little bit greater than 1, those are all 1. Okay, let's take a look at the questions here for this state park histogram. How many data points were used to create this histogram? All right, so we're going to just count up the data points or add them up. So 2 plus 7 plus 8. Each bar shows us the number of data points for that interval. So we're going to add up the frequencies. Let's see what we get. 2 plus 7 is 9. Plus 8, 17. And then there's 3 ones here, which would be 20, which is the same number of data points we had when we made our state park visitors histogram yesterday. All right, question 2. How many days did 200 or more visitors visit the park? So 200 or more. Let's see. Well, these two intervals are less than 200, so we're looking at the ones that are 200 or more. So we have 8, and then 1, and then 1, and then 1. So we have 8 plus 1 plus 1 plus 1. Those are all 200 or greater. So we have 8 plus 1, which is 9, plus 1, which is 10, plus 1, which is 11. So what's nice about histograms is oftentimes the questions are a little bit easier to answer because you don't see the individual data points. But I guess that's the drawback too, is that you don't see the individual data points. So there's not much you can say about them. All right. Number 3. On how many days did between 100 and 249 visitors visit the park? So 100 and 249. It's going to be kind of, I'm just going to put a little tally there. That's going to be between these 3 intervals here. So that's 2 plus 7 plus 8. Whoa. Okay. 2 plus 7 plus 8. 2 plus 7 is 9, plus 8 is 17. That's how many days? 17 days. Which intervals have 1 data point? Well, there's a couple. Actually, there's 3. Okay, the intervals there are 3 of them, 1, 2, 3. They each have 1 data point, which means on one day, between 250 to 299 people came, and on one day, somewhere between 3 and 349 people came, and 350 to 399. So there were only 3 days where 250 to 399 people came out of 20. So that's not really that frequent. Okay. So we're moving on to a couple. We're going to look at a couple different histograms at once about class sales. And again, before we answer the questions, I'm just going to take a look at the numbers, the frequencies. These are a little bit harder to see. I'm just going to zoom in a little bit because it's going up by 5s. So I'm going to do my best to find an accurate number for each frequency bar here. The first one's a little easier. It's 15. So we're at a little 15 here. 200 to 399 is going to be like 26, it looks like, 26. 400 to 599, I'd say, is about 18. 600 to 799 is 9-ish. And then 800 to 999, I think, is right on 5. It's a little hard to tell, but those numbers will work for us there. All right, let's look at 7th grade. The 7th grade sales, I wonder what they're selling. Doesn't say. Doesn't say. All right, so 0 to 199, like 20, say like 27. Yeah, 27. No, 28. Sorry. 200 to 399, that's going to be 14. Pretty sure about that. It's a little bit below. 400 to 599, I believe, is 16. It's just slightly above. 600 to 799, it's right in the middle, but couldn't have 7.5 students. So I'm going to say that's 7. 800 to 999, we'll say that's 3. Okay, it's a good start. Okay, we got numbers to work with here. It says, which class had more students raised between $600 and $999? So what we have to do is compare both classes. And to do that, I'm just going to make a little tiny, I wouldn't call it a chart really, but this will be for the 6th grade. We'll count how many people sold that many in 6th grade. And then 7th grade will be right here. Well, let's look at the 6th grade interval between 600 and 999. Between those two intervals, 9 plus 5 would be 14 people. And let's look at those 600 to 999 for 7th grade. 7 plus 3 would be 10. So who had more students raise that much money? That would be the 6th grade. Go 6th graders. Nice job. Which class had more students raised between $0 and $399 is our next question. So now we're looking at a different interval here. I'm going to do the same thing I did on the previous question. Look at 6th grade. I'm going to look at 7th grade. Let's see, here's 6th grade. Between 0 and 399, that's going to be 15 plus 26. Well, 15 plus 25 is 40. So 15 plus 26 is 41. 41 people from 6th grade. And then, it's going to be close. 28 plus 14. Well, 28 plus 12 is 40. So 28 plus 14 would be 42. So slight edge. Slight edge on the 7th graders. Just one more 7th grader sold between $300 and $399. It says, which interval represented the most number of sales for each class? So we're going to take a look at each class. Looks like which interval had the highest frequency. For 6th grade, it would be 200 to 399. So 6th grade, more people sold between 200 and 399 than any other interval. And then 7th grade, different story there. More people sold between 0 and 199 than any other individual interval. 0 to 199. So that wasn't really looking to compare, it's just wanting us to see which had the most sales for each class. Can you tell from these histograms which class sold more? Why or why not? Now, to answer this question, this is a tougher question. If you look at an interval like this, 0 to 199, 28 people sold 0 to 99. And then you look at 6th grade and only 15 people sold from 0 to 199. Just looking at this one interval, can you tell which class sold more? The answer for a histogram would be no. Because let's say, even though there's more people here, let's say all 28 people in this histogram, in this interval for 7th grade, sold $1. So that means they would have made $28. But let's say these 15 people, it's any number between 0 and 199. Let's say they all sold $100. That would be $1,500, which would be 1,500. Now, I just made those numbers up to show that even though there's more people here in this interval, we don't know how much they sold because it's anywhere between 0 and 199. So is this one too, right? The intervals are the same. So we can't tell because we don't have the individual data points. So can you tell from these histograms which class sold more? No, because, and this is kind of like the drawback, I guess, of a histogram. We don't have the individual data points. Okay. All right. So sometimes you just can't get a definite answer. And we can't really take a guess either because again, we don't know, who sold what in those intervals. All right, let's go on to the next page. Let's look at a couple more histograms here. Olympic men's cycling trial times. Ooh. All right, so we have 0 people that finished 55 to 59 minutes. We have, it looks like 9 people finished between 60 and 64. This would be seven people between 65 and 69. 5 people between 70 and 74. And 3 people between 75 and 79. All right, it says, what does the interval 0, or with 0 finishing times represent? So 0 was the frequency for 55 to 59. And that means that no cyclists finished in that interval. So no one, that was in the time trial finished between 55 and 59 minutes in. That's all that means. All right, which was the most common interval for cyclists to finish? The interval that had more data points than any other was here. It's 60 to 64. 60 to 64 minutes. That doesn't mean most cyclists finish in that time, because that would have to mean that interval had more than half the data points, but 9 is not more than half. So it just means that it had more than any other interval. So between 60 and 64 minutes. How many cyclists finished the time trial in 65 to 74? So that will include two different intervals. Okay, and so 65 to 64, I'm going to just put a little dash here, 65 to 74, I'm sorry, is these two intervals right here. So 7 cyclists here, 5 cyclists there. It's going to be 7 plus 5 cyclists, which will be 12 cyclists. Okay. Seems to be quite a race. I mean, you could go pretty far on a bike in an hour. So I wonder how far that they were going there. How many cyclists competed in the time trials? And that's where the frequency comes in handy. So we're going to count the number of cyclists, or the number of times that were counted in this time trial to get how many cyclists there were. 0 plus 9 plus 7 plus 3 plus 5 plus 3. 0 plus 9 plus 7 plus 5 plus 3. 9 plus 7 is 16, plus 5 is 21, plus 3 is 24 cyclists. Okay. All right, describe the shape. All right, clusters. Well, clusters, again, is where there's a lot of data in a small space. I would say that, I mean, you could probably say, and it would make sense, that there's a cluster between 60 and 64. But I would even include this interval here because 9 and 7 are pretty high numbers compared to the other two. So I might say there's a cluster between 60 and 69, that there was a lot of data points in those two intervals combined. So we'll say that that's a cluster. So we'll say there is a cluster. Cluster from 60 to 69 minutes. Okay. Gaps. Now, you might think this is a gap, but a gap has to be between data points, and there's no data points to the left of that 0, so there wouldn't be a gap because we have data here, but there's nothing on the other side. So there are no gaps. It would have to be between data points. So we'd say there are no gaps. Are there any peaks? The peak interval would be 60 to 64. That had the most that interval had the most data points. So the peak is, the peak is at the interval 60 to 64. All right. That's kind of what the data looks like. That's the shape of the data. All right, last one here. Ages of players on a baseball team. Okay. So we can see all the players of the baseball team are either between 20 and 39 years old. We'll see how many players are in each interval here. 20 to 23, it's going to be 6. 24 to 27, between 10 and 12 is 11. 28 to 31 is 4. 32 to 35 is 8. 36 to 39, there's only 1. There's only 1. That could be me, I guess. All right. It says, which interval has the least number of players? Why does that make sense for this histogram? So the interval with the least number of players is 36 to 39. Okay, so which numbers? We don't have a lot of room here, so I'm just going to write 36 to 39 has the least. And why would that make sense that the least number of players are between those ages? Well, if you think about it, this is like players on a sports team. Typically, you're going to have younger people on the baseball team, so you might say that baseball is a younger person's game or something like that. Younger person's game. So I guess the older you are, the less likely you'd be on a baseball team, I suppose. How many players are on this team? Well, again, that's why it can be helpful to write down the frequencies, because we can just add those numbers up. Each interval shows us how many players are within those ages, so we'll add up the frequencies. 6 plus 11 plus 4 plus 8 plus 1. 6 plus 11 is 17, plus 4 is 21, plus 8 is 29, plus 1 is 30 players. Okay. What percentage of players on the team are between 20 and 23, which is this interval right here? So that's when we're going to need part of a whole equals percent over 100, which we are experts at. So what percent of players? So there are 6 players on the team in that interval. 6 is going to be the part. How many total players are on the team? That total is going to be 30. Whoops, probably can't see that too clearly. There we go. All right. And we want to find the percentage, so we're going to put a little circle there out of 100. We can't get from 30 to 100 in one step, so we're going to have to simplify the 6 and 30. What can we divide by? We can divide 6 and 30 by, well, we can divide by 3, actually. I was going to say divide by 6, but it might be easier to divide by 3 because 30 divided by 3 is 10. 6 divided by 3 is 2. And then we can get from 10 to 100 by multiplying by 10. 2 times 10 is 20. That would mean 20%. So that means 80% are not those ages. 80% are older than 23. Okay, it says most players on the team are between 24 and 27 years old. Is that true? Well, how many players are between 24 and 27? There's 11. So that means there are 11 players in that interval out of, how many total players are there? 11 out of 30. Is that most? That is not most. That's less than half. You'd be able to say most if it was more than half, but if it was like 17 or 18 or 23. But since this number is less than half, we can't say that it's most. Looking at it might look like it's most because that interval is more than any other, but we might just say that there are more 24 to 27-year-olds than any other interval. Doesn't mean that most players are between those ages. So, is this false? This is false. Okay, this is false because 11 out of 30 is less than half of the total players. Okay, well, that was analyzing some histograms. We got some information. Again, we can't get all the information we maybe would like because we don't have the individual data points, but we have enough to answer a few different types of questions. If you have any questions for me, let me know. If not, have a great day, and I will see you soon. Bye-bye.